All right, hello everyone. Great. I think you can hear me, yes? Okay, so fantastic. So this is also going to be just, giving you an overall idea. This is also going to be about Copilot. It's not going to be about the business version, but about another kind of access that you can get. We're talking about individuals that we call linchpin maintainers. But in general, the basic idea of this paper is we are interested in generative AI and how it impacts distributed work overall, where the context of open source software is just one of those contexts where it's very easy to measure with a lot of high quality data where we can say something a little bit more broadly speaking. But so to motivate this, I want to point you to what's this kind of graph. If you're a computer scientist, you've probably seen this a bunch of time. If you're not, maybe not. So you can see here all of our modern digital infrastructure. There's a huge machinery here, right? And then there's this little piece. That's a project that has been thanklessly maintained by a person in Nebraska since 2003. So just think about this guy, and now take away this person. You could imagine that this whole machinery, our infrastructure may crumble and fall apart. That's the worry of quite a lot of people when you're talking to a computer scientist and how our infrastructure actually works. It also tells us something about particular individuals being really important in our society. We call those linchpin individuals. And they are high-skilled individuals, and we want to see if we can see what kind of impacts AI adoption has on the distributed work patterns of those linchpin individuals, and whether it may assist those individuals in particular. So when we're talking about linchpins, we're talking about maintainers of open source software, I probably don't have to say this, but in any event, open source software is is licenses. You have some permissive licenses, and you can use that freely available software the way that you like to use it, and it's very pervasive. You can see this everywhere in society nowadays. I think by some estimates, 96% of all of software contains some open source software. And we have a natural experiment where we are looking into a discontinuity in GitHub's Copilot program to offer free coding AI to some top maintainers and not others through the same channel, where just as a main takeaway to give you the story, what we see is people allocate their time more towards their core work, which is code, which we think is coding in this environment, and they engage less in what we call what is non-core work, what we call project management. We see the same story that you've seen over and over again. The lower ability individuals seem to be particularly driving those effects, but the high ability individuals also point in the same direction. And this is a natural experiment where we can say something about the long-term effects. So this is a study over 2 years. So we're adding a little bit more to the literature on top of what the current RCTs are providing. So going back to this idea of linchpins, we think you could think about organizations. In organizations, particular individuals could be very important. We think that here, linchpin individuals are interesting in a public goods context, like open source in particular, because you can freely enter and exit, and you have around 50 projects that rely on a single individual, 50% of projects that rely on a single individual. You have 5% of developers by some other estimates of ours that generate 96% of the value. So it's a particular important group of individuals, and we think this kind of dependency on those linchpin individuals is further worsened in a setting of distributed work, where you cannot just stop by at the office of to somebody and talk to them in person, but you may actually shoot them a quick message, and that is substantially easier. So think about the internet, right? The internet is a fantastic invention. It lowered communication costs for all of us. Now we can talk to each other for a long time very quickly, but we won't, because we will focus on a couple of individuals that are particularly important. So those are the individuals that are then burdened substantially. And so we think maybe there's a way how those burdens could be reduced on those particular experts. So we have this dichotomy in mind on how individuals operate in the information economy in general. And I think that applies to our case as well, where you're either engaging in, let's say you're a researcher here, and you're engaging in some kind of core work, maybe that's research, and then you have a bunch of other things going on that might be more managerial by nature. Maybe you're organizing a conference, or you're doing something else that is not exactly research or teaching, and you may complain, hey, this is not what I like. I'm doing too much of the kind of non-core work. I would like to do more of the core work, right? And this is kind of the same idea for developers. They complain that, well, we are doing too little of the core work, too little coding, and too much project management, where I have to interact with other individuals, solving bugs, problems, maintenance of projects, and yeah, I'd love to do more of my core work. At least we have some reported preferences there, and based on some surveys. So the question is, can AI help us to maybe substitute away from those scarce resources? And in particular, we are going to look at open source software programming, where AI could, to borrow the metaphor of Microsoft and GitHub, to add a pair programmer next to you and maybe substitute the advice from other developers. So we're asking, how does AI change the nature of distributed work in the open source software production setting? Can it change task allocation in particular, and maybe relax what we call the linchpin constraint? There's a bunch of literature, mainly on the productivity side, and similar to what was presented by Matthew before. We're trying to go beyond what are the general productivity effects to look into the nature of work. We look into AI impacts of the private provision of public goods with the long-term causal evidence from a real-world scenario. So this Copilot AI from GitHub for top developers, where we can trace work activities on the platform, on the biggest platform of open source software production, where we can estimate local average treatment effects at a particular threshold using a regression discontinuity design. So GitHub is great because it has basically a time-stamped history of the work that developers are engaging in. If you're not a developer, if you use, maybe you're writing something on like a Word document in Google Docs, you can go back in the version history and go back to a previous version, right? And that's the same idea for developers with GitHub. And the main benefit is that we have granular information on the two dimensions of core work, coding, and project management. So you can see, bless you. So you can see here an example of one project, which is basically showing you the coding, where we're capturing the coding activity. So yeah, anything on the coding tab is basically coding activity that we are capturing. And then what we call project management is really an issue tab, where you're interacting with other people, you're pulling them in to solve problems and yeah, fix problems or think about feature requests or the like. Now, as announced before, right, we have GitHub Copilot that was created by OpenAI and Microsoft with GitHub, and instead of thinking about next word predictions, we're thinking here about next code completion. So just think about writing a function header, and Copilot is going to do the rest. Now, how GitHub Copilot was deployed was a technical preview period in the summer of 2021. Then general access, it was given for not for free, but was provided to the general public as a paid version a year later in 2022, and there were a bunch of versions where you could also get access for free. One of those versions is a top maintainer version, and so we're going to use that with an intervention period of 2 years, looking at coding and project management, where GitHub introduced this this kind of access channel with the idea that they wanted to reward those top open source maintainers that provide benefits to the public good by giving them free access to the tool GitHub Copilot. They create an internal ranking at the project, at the repository level, and you are going to be associated with that ranking. And based on that ranking, individuals that are below a certain threshold, here below 0, they get free access through the channel, and the others, they don't. So think about that as basically people are on average the same on the left and right hand side of the cutoff if you're close enough. Think about that similar to an RCT in the real world, close to the cutoff. And so one worry is maybe there's some kind of potential manipulation that is going on. Maybe people could sort from the right to the left and get eligible for Copilot. Well, to give you an idea of the knowledge of the ranking, here's a question on GitHub Copilot. GitHub Copilot is available for free as of right now to verified students and popular open source projects. What GitHub defines as popular open source project is sadly not expressively stated. Well, that is very sad, and not for us. For us, it's fantastic because now it's very difficult to actually manipulate if you don't even know how the ranking is constructed. So use the standard RDD, where the identifying assumption is that the outcomes change only at the threshold due to the usage of AI. All right. So we construct, as our main versions, a cumulative measure of activity over total cumulative activity for coding and for project management. We also have absolute measures that looks very similar. And then we have information on Copilot usage, as well as the top maintainer ranking. We have a balanced maintainer week panel with around 180,000 linchpins, 6 million observations, but we're going to home in and use only around 230,000 observations to say something causally here. All right. So this is first, what we call the first stage, right? We see Copilot usage, and we see on the right-hand side, those are individuals that are not eligible through this channel. You see they're using Copilot. That's because they get access to another channel, which is a free trial. But we also see when you're crossing the threshold, you go to the left, you become eligible, and you're in the treatment group, your Copilot usage goes up dramatically. We see at the cutoff an increase in the relative frequency of coding and a drop in project management. So what that tells us is, for us, it's intuitive in the sense that, well, you get this tool that increases your efficiency. Now you can decide what you do with that. Well, people seem to tend to engage more in their core work, because that was their stated preference before, and they're engaging less in project management. And if you think about that, it's because they're solving problems that they can now solve by themselves, where they don't need other people anymore. And we can kind of see this in the granular measures as well. Here you can see split up the treatment effect for coding. This is push commit, so the main autonomous activity that you're engaging in to upload code on the platform. And you can see that goes up, it's driving the measure. But then you can also see something like creating pull requests or forking repositories, which are by nature collaborative. You need other people to do that, or that's the intent for forking. And we see those measures of collaboration going down, autonomous work going up. We see that similar for the project management, where you can see issues that are being closed or merged, that increases, but the whole measure overall goes down, and it's driven by not bringing other people in and assigning them to work to solve problems or to review code. We see the treatment effects on coding for around the 2 years being still stable after this whole 2-year time period. And we see a similar effect. It is a little bit stronger in the first year, and then it attenuates. And we see that also for project management. As announced, we have a bunch of proxies on ability, and we see the high ability individuals, they're engaging more in coding when they receive generative AI, but the low ability individuals do that even more. And we see a similar pattern for project management. High ability individuals engage less in project management, but the low ability do this even to a substantially lower degree. So we have a bunch of robustness checks that I won't go through here, but the basic idea is we try to emphasize here the nature of work, exploit a natural experiment with the causal interpretation for 2 years of AI usage in the real world, and we find that the core work goes up, project management goes down, treatment effects for over 2 years, which is driven by low ability individuals in particular. We think generative AI can have a positive impact here on the public good of open source software and on distributed work overall. If we want to take that to the context of organizations, you can think, well, project management goes down. If this is transferable, this may imply that maybe AI has the potential to flatten organizational hierarchies. Right. Thank you.
Do you have any questions?
Thank you. The results are very interesting. Maybe you already said this. Can you help us understand why this is happening? Why is the project management going this way versus the other?
Sure. Yeah, gladly. So it's basically, and on the project management side, you have to deal with the problems that appear, right? Like you have to solve issues, and often what programmers are doing when they're working collaboratively, they're bringing in another programmer and telling them, hey, maybe you should solve this problem. But now you have generative AI at your fingertips in the integrated developer interface when you're programming, and what we think is happening is you're just solving the problem by yourself, so you don't need to assign anybody to solve a problem that you can solve by yourself. Yeah. Thank you. Good point.
For another one?
Yeah, thank you. So I guess, have you looked at any measures of the overall quality? So one of the things is like pull requests are, in some sense they're project management, but in other sense they're quality control. So like, does this mean that the overall quality is sort of getting diminished? Or is it that like, in fact, this is just efficiency and overall quality is not in any way sort of affected?
Yeah, also a great point. So we have, I don't have the results here. We did some preliminary analysis on, for example, what developers tend to do is they label problems. And so that helps us out to understand whether something is a bug or is a feature request, which are the two main things that are happening most often. And we find that when you look into bugs relative to feature requests, as an overall measure, that the bugs tend to go down, actually. So we have some indication that this may actually not be harmful code that is being put out in the real world, but we don't have the exact code for each project. But yeah, it looks like it seems to be beneficial. Yeah, thanks.
All right, thank you so much.
Thank you.